Indian Machine Tool Manufacturers Association to this short video on the power and use of variable search methodology in doing process characterization and optimization. In our industries, we have so many processes. For example, we have machining processes like CNC turning, milling, grinding, drilling, etc. We also have injection molding processes, pressure die casting process. We have welding process like MIG welding, spot welding, TIG welding. Now we all know that all these processes, there are parameters which we need to set in the machine to run the machine. All these parameters are identified by the process engineers before the start of the mass production. Now, all these parameters will have a direct impact on cycle time and cost of production. For example, if you take a grinding machine, there are parameters like spindle RPM, slide feed rate, which have a direct impact on the time of production. Plus, we have some wheel related parameters like dressing depth, dressing frequency, and dressing feed rate, which has a direct impact on wheel consumption and obviously on the cost of production. Generally, most of the industries, all these parameters are not identified in a scientific methodology. So generally, if you ask a process engineer on how he has arrived at the value of these process parameters, say for example, the spindle RPM is 3000 RPM in a grinding machine. Generally, the answer is through gut feeling, which is generally termed as atmospheric analysis. Because of this, we lose a lot of productivity because the parameters are not set at optimal condition. If we have a scientific method through which we can arrive at the optimal value of the spindle RPM and feed rate, etc., without compromising on quality, then we can get the best and maximum from the production process. Variable search is a simple and very user-friendly methodology through which we can arrive at the optimal condition of any process parameter. So to have a snapshot of this methodology, let me take you through the steps involved in the variable search tool. So now here we have a grinding machine. Now these are the controls in the grinding machine. Now this is a component that has been ground. It is an OD cylindrical grinding process, and these are the three quality parameters: surface roughness within 6 microns, taper within 3 microns, and circularity within 10 micron. And these are all the three parameters which have been identified, which has a direct impact on the wheel consumption. So the theme of this project is to optimize the parameters for reducing the wheel consumption. So now let's see how this tool works. It's very simple. Now for every parameters which has been identified based on the theme, here is the current condition, which is the present one in which the process is running. And we identify a new condition where we have a direct benefit towards the theme, but we are not sure what will happen to the quality. So through simple trials, we collect data and identify whether the quality will get affected or not. So for example, here is the data collected for surface roughness. So this data shows that the quality is not getting affected through a simple calculation called D/D ratio. So like this, it's been done for taper. So this also shows that the D/D ratio is 0.09. So there is no difference in quality. But here for circularity, you can see that there is a difference in quality. So in the training program, we will be teaching you the systematic methodology on how to collect the data and how to analyze and how to identify whether the quality is getting affected or not. So now circularity is getting affected. Now the next step is which parameter is having an impact on circularity. So this is done through simple graphical method where they have found out that two parameters are having an impact on circularity, which is A and B. So when you go back, A is dressing frequency and B is rough dress depth. So these are the two parameters which have an impact on the quality parameter. Now the next step is, once we identified that these are all the two quality parameters, now we need to identify what should be the optimal condition for these two quality parameters. So here we'll be using an analysis called factorial analysis, through which we will identify the contributions of these quality parameters, and through a simple Excel table we can identify what should be the best condition for the parameters which are having an impact on quality, which in this case is dressing frequency and rough dress depth. So based on this, through this table they've identified that the dressing frequency has to be 80 numbers every 80, and the dressing depth should be 20 micron. So here is the final optimal setting. Dressing frequency is every 80 numbers, rough dress depth is 20, and fine dress depth is 10. Now you can see the drastic difference between the existing and optimal condition. Now the existing condition is every 50 numbers dressing is done, but now we are telling we need to do every 80, not every 50. And dressing depth, currently the depth is 25 micron, but we are now optimizing and telling that the depth has to be 20 micron for rough and 10 micron for fine. So after this, there is a systematic procedure to validate, which is very, very important, which we'll be discussing in the training program. And after this validation, now here is the result. Now the wheel life before, it was 2,22,250. Now with the optimal condition, it's 5,33,280. This has been done without compromising on the product quality. So now here is the team from Titan who has used this tool in one of their projects, who will be explaining the project in detail.
I'm Dinesh Raj, working as a manager in manufacturing division. We are here to explain about a project we have done for a guideway. So in our division we have done overall 20 projects. In that 14 projects is from process optimization. Cycle time plays a major role in our organization, which in turn directly affects the profitability of the business. So we are here to explain about a project called Guideway. We have done the project using a variable search tool. My colleague Mr. Ramnarayan will explain about the project in detail.
Hello, I am Ramnarayan. I am working quality control. This part called for inlet gate event. This part two parameters very, very critical and close. One is outer diameter, another one is surface finish. Outer diameter tolerance is 10 micron, surface finish tolerance is 0.8 micrometer. This part used in aerospace synthesis, and this part made from titanium material, made in thermal machines.
Current speed is 700 revolution per minute and the feed is 0.06 mm per revolution. The cycle time is 240 seconds. By using the variable search tool, we have redesigned the parameter and the speed now is 1000 revolution per minute and the feed is 0.086 mm per revolution. And now the new cycle time is 135 seconds. Thanks to Mr. Ram for guiding us through the project.
So in IMTMA, we have designed a 5-day program on the use of this tool called variable search. The first 2 days will be a classroom session where I will be explaining you how to identify the theme, how to identify the parameters, and how to do trials, how to collect data, and all those things I explained. Now after that, we will have a gap of about 20-25 days where you will go back and apply the learnings in your shop floor, and then we will have a 1-day interaction through web where you can ask your doubts and I will facilitate you on the projects. And after a gap of about 25 days, we will have another 2-day training module and a formal closure to make sure that the learning has happened properly. Thank you, and see you all during training.